Picture the solar system gone, not exploded, replaced. Where the sun used to sit, put a shadow so wide it would swallow Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and keep going roughly 40 times past Pluto before the edge finally ends. That is not a black hole eating a solar system. That is the size of the mouth. That mouth belongs to TON 618. NASA-scale figures put the black hole inside it near 66 billion times the mass of our Sun. Its event horizon stretches on the order of 390 billion kilometers across, about 2,600 times the Earth-Sun distance from one side to the other. Light can loop Earth more than 7 times in a single second. Here, the darkness is measured in light days. If you fell straight across that boundary at light speed, you would still need days just to finish the trip from edge to edge. And here is the part that should bother you more than the size. Imagine flying toward that black circle. Your ship is not shaking, your bones are not stretching. No alarm announces the last exit. Then, without a wall, a flash, or a sound, you cross a line you can never cross back. Human engineering usually prints a warning label. TON 618 prints causality. Convenient, isn't it, that the most important border in space can feel ordinary from the inside of your own body. So the real puzzle is not only why this object is enormous, it is how the universe assembled something this extreme while the cosmos was still young, and why the quietest part of the trap may be the door itself. A black hole is easiest to picture as a drain that does not pull because it is magical, but because so much mass has been packed into so little space that every nearby path bends inward. The event horizon is the line where all roads point the same way. Past it, even light cannot choose a route home. TON 618 is not bright because the black hole itself shines. Black holes are dark. What we see is the violence around it. Gas falling inward does not drop like a clean coin into a slot. It spirals. Pour water into a narrow funnel and watch it fight itself on the way down. In space, that fight becomes friction, heat and radiation. The whirlpool is called an accretion disk. When the feeding is fierce enough, the whole engine becomes a quasar, a beacon announcing a hungry giant across the universe. TON 618 announced itself from more than 10 billion light-years away. In 1957, astronomers Braulio Iriarte and Enrique Chavira recorded a faint bluish object at Tonantzintla Observatory in Mexico. It became entry 618 in their catalogue. Quasars were not even a settled class of object yet. Later radio work and spectroscopy showed the truth hiding inside that innocent point. Ancient light from a central engine outweighing the black hole at the center of the Milky Way by more than 15,000 times. Sagittarius A, our galaxy's black hole, holds about 4 million suns. TON 618 holds about 66 billion. Comparing them is like comparing a house key to a suspension bridge and pretending both belong in the same drawer, but mass is only the first insult. Time is the second. A dying star can collapse into a stellar black hole only up to a point, usually tens of suns, rarely near 100. Think of a sandcastle. Pile the sand too high and it fails under its own weight before you can keep stacking. Stellar black holes hit a natural stopping point constantly. TON 618 blew past that scale by hundreds of millions and kept going. To grow the honest way, a black hole eats gas and dust, but feeding is not filling a bucket. As matter spirals in, it heats up and shines. Light is not just something you see. Light has momentum. It pushes. Pull matter in too fast and the disk gets so bright that radiation shoves the next meal outward before it can fall. Gravity pulls in. Light pushes out. When those forces balance, growth chokes. Astronomers call that ceiling the Eddington limit. It is less like an unlimited buffet and more like trying to feed a furnace while the furnace blasts the food back into your face. The thermostat locked in place by gravity and light. For something with no plan, the universe shows up with a remarkably clean braking system. Now, run the clock backward. The light we receive from TON 618 has been traveling for more than 10 billion years. We are not looking at a modern giant with all of cosmic history to bulk up. We are looking at a monster already huge when the universe was far younger than it is now. A black hole feeding politely at the classical limit, starting from a modest stellar seed, wants on the order of 10 billion years to approach a mass like this. TON 618 did not get a leisurely 10. It had a much shorter runway. That is not a slow drain filling a bathtub over a lifetime. That is the tub already overflowing before the tap finished turning on. In 2015, astrophysicist Andrew King calculated that for typical bright accretion disks, there is a practical mass scale around 50 billion suns, above which continued luminous disk feeding becomes difficult. Extreme assumptions can push the ceiling higher, up toward a couple of 100 billion suns. So TON 618 does not hand you a cartoon headline that physics is broken. That distinction matters. Physics is broken is what people shout when the real answer takes another sentence. TON 618 is more interesting than a broken law. At roughly 66 billion solar masses, it lives in the uncomfortable territory where our simplest growth story stops feeling simple. Researchers propose heavy seeds, dense early gas, long feeding episodes, faster than Eddington bursts, mergers, candidates, not a closed case. One popular patch is direct collapse. Skip the small stellar seed and let a colossal pristine gas cloud fall straight into a heavy black hole. Clever. Also, so far, a shortcut demanded by the timeline more than a process anyone has casually watched happen in the act. If the cloud fragments, you get stars, not a perfect seed. If pressure wins, the whole attempt puffs apart. The tolerances sit on a razor. Randomness, apparently, took the hardest fluid dynamics exam in the early universe, and the answer key still looks suspiciously neat. Here is the pattern interrupt that rearranges the fear. You might assume the biggest black hole must own the most violent doorway. Not necessarily. Tidal force is the difference in gravity between your head and your feet. Near a small black hole, that difference can become monstrous before you reach the horizon. Near an ultramassive one, the horizon is so wide that the change across a human body can be far gentler at the edge. NASA astrophysicist Jeremy Schnittman has put it bluntly. If you had to fall into a black hole, you would choose a supermassive one. For TON 618, the thought experiment turns absurd. Ignore for a moment the real quasars' lethal radiation and plasma. In the clean, idealized fall, you could cross the event horizon without a local sign that says, "You are now trapped." No bump, no gate, no cosmic customs officer checking your return ticket. One moment escape is still physically possible. The next, every future path leads deeper in. That may be the scariest property of all. Not cinematic crushing at the border. The border can be ordinary from your point of view. The universe does not owe its most important boundaries a visible line. An accident that keeps passing the engineering review, including the part where the exit disappears without drama. If humans could command even a fraction of the mechanical efficiency around an engine like this, energy and propulsion would become a different civilization. The gravity well of a feeding supermassive black hole can turn a large share of falling mass into radiation. Far beyond the tiny sliver, a nuclear reactor rings from matter. Theorists sketch ideas like the Penrose process, borrowing energy from a spinning black hole's space-time twist. It sounds like the ultimate power station. Then you look at what we can actually hold steady. The ITER fusion project in France has consumed decades and tens of billions of dollars chasing a controlled, self-sustaining plasma. The goal is net gain on human timescales measured in minutes and years, not geologic ages. Containment walls still threaten to become the weak link. NASA has chased advanced propulsion concepts for generations and remains honest about how far practical breakthroughs still sit. In 2019, the Event Horizon Telescope collaboration managed the first image of a black hole's shadow in galaxy M87, not TON 618. Ground detectors hear stellar mass mergers as space-time ripples. ESA and NASA are building LISA, 3 spacecraft planned for the 2030s, separated by millions of kilometers, so we can listen for low-frequency gravitational waves from giant black holes moving across cosmic history. That is our current mastery. We are assembling an instrument millions of kilometers wide, so we can hear giants move. The universe already built the giants. A hydrogen atom sliding through TON 618's engine does the hard part without a committee, a cooling schedule, or a press release. We struggle to keep plasma polite inside a vacuum chamber. The cosmos runs a 66 billion solar mass power plant in deep space and makes the operation look calm from 10 billion light years away. And we call the whole stack an accident because the alternative is uncomfortable. Line up what is on the table. A mass near 66 billion suns. A horizon measured in light days. Light older than familiar continents still arriving in our instruments. A feeding break, the Eddington limit, woven into light and gravity. A youthful cosmic clock that refuses to hand the simple story spare time. A doorway that can vanish behind you without theater. Equations that describe the horizon with extraordinary precision. Simulations that grow black holes inside virtual galaxies. Telescopes that catch ancient quasars as faint blue points. Describing the machine is not the same as knowing how the early universe assembled this one so completely, so early, so quietly. Ton 618 is scary because it is huge. It is scarier because the rules stay calm while they produce an object that makes our solar system look misplaceable inside a dark circle. No fireworks required, no local siren required, just mass, light, time and a boundary drawn by geometry. 66 billion suns, a horizon wide enough to lose planets inside. Ancient light still completing its commute. Growth paths that force our neatest models to sweat. A silent line where causality changes its mind about exit ramps. We can name the limits, we can propose the seeds, we can fund the detectors, we can argue about super Eddington bursts and heavy beginnings. After all of that, one question remains uncomfortably intact. Who calibrated a universe where limits this strict still permit an engine this extreme, this early, this orderly, if no one calibrated it at all?